So up next, we have Ask from Hyme. So Hyme are a Danish molten salt pioneer, retrofitting cogeneration facilities for clean heat and power. Thank you.
Thank you. Let me just share my presentation.
Perfect.
Yeah, so hello, everybody. As mentioned, my name is Ask, and I'm the CEO of Hyme Energy. We are a Copenhagen-based startup. I believe we're actually one of the youngest companies here today. We are 2.5 years old. But we've done some of the technology development ahead of the founding of the company, which is also why I'm very proud of the achievements and outlook we can show today. I'm going to touch briefly upon what you already presented very well earlier on. I think there's a huge gap today, technology-wise, in ensuring that we can transfer all the intermittent sources into heat. Let me just be very specific. Denmark has just announced a 6 gigawatt offshore wind farm deployment outlook. And that's going to mean that we will have 300 to 400% of the power needs, electricity needs in Denmark covered. And that's one of the enablers to actually decarbonize the heat sector and the industry sector. But it is only if we can shift that power in time and across sectors. I'm glad to come after some very, very excellent presentations, ladies from Malta, on a very exciting technology, also for power to power application through molten salt. Hyme has gone a different route and focus entirely on storing power in molten salts for large-scale energy storage for industrial decarbonization, specifically for process steam and utility cogeneration. And just to give you a bit more flavor of what is at the core of Hyme, we use a novel type of salt, the group that is called hydroxide salts, where you are likely most familiar with sodium hydroxide or caustic soda. They are extremely interesting. First of all, because they're produced from salt water, literal salt water. It means it's a global commodity. It's inexpensive. But what is also very, very attractive are the thermophysical properties, the energy density and the temperature span, and the heat transfer capabilities. In short, enormous amounts of energy can be stored in just 1 liter of the salt. It's obviously sustainable, but it's also non-toxic and unflammable. For a product, this means that we can build with a low spatial footprint, which is important for some of the cases, specifically in the large-scale industry deployment. It also makes it safe and easy to adapt in that setting. And maybe to just give you an insight to what is one step below that in our technology, or deeper than that, it's Hyme unique and patented chemistry control system that allows us to get the lifetime in materials using hydroxide salts. And just to give you an idea of what I think is one of the very attractive benefits of molten salt storage, and specifically hydroxides, this is the layout of a 1 gigawatt hour storage. The site is actually modeled based on one of the dialogues we have in Western Denmark of an industry facility producing in the food sector. They today use natural gas just to produce steam at above 200 degrees Celsius. It's constant temperature, constant pressure needed 24/7, more than 11 months a year. And this would be the actual size and footprint of a gigawatt hour storage. And I think that shows one of the benefits of thermal storage in general, not just Hyme, but also other technologies. It would be a 75 by 35 meter footprint, including the switchgear and auxiliary systems for that. We work with on-grid deployment cases for nearly all the dialogues we have, because there is a benefit of the ancillary services, not just on the discharge side, but also on the chart side that has already been mentioned. Hyme's focus is particularly on the medium to high temperature steam, and for longer batch processes up to the 24/7 discharge. So working with a design that can charge and discharge simultaneously and independent of each other, that can have an overcapacity on the chart side, so we can utilize the 6 to 8 hours of inexpensive power in a 24-hour cycle, and have from 8 up to 24 hours of constant discharge of steam or cogeneration through a turbine system. It's a technology where the storage medium is so inexpensive that it becomes the smallest part. It's less than 10% of the capex of a large plant. And that means that we're focused on deployment of 100 megawatt hours and larger in commercial settings. That's where the technology really becomes cost competitive. And that means discharge from typically 20 megawatt thermal up to 100 megawatt thermal in one plant. And instead of market data, I actually brought a very specific case and numbers from one of the sites in Denmark of one of the customer dialogues we have there. From the left, it's the current natural gas price that industry client pays, including taxes. The second would be the cost of electrifying that 100% through an electrical boiler. It is a 360 days a year, 24/7 demand that the site has. And the last is a price that we can offer as power as heat to that customer using existing tariffs in Denmark, known power prices from also with the outlook from national bodies, and the existing tax that is on it. So it's without assuming that things become more favorable for storage in the future. And this is, of course, the value driver of why would a customer shift to a power as a heat solution there. It allows for not just meeting the 2030, but even the 2050 goals of the industries in decarbonization, up to 100% electrification, or even hybrid solutions where a natural gas kettle is kept as a backup running on biogas in the weeks of shutdown that we might have. We focus specifically on some of the sectors and the verticals in them that has already been mentioned. It's particularly the chemistry sector and paper and pulp to some degree, but also the food and dairy sector, which are very interesting and has a very large volume. And then I think it's interesting to see that we also have customers approach us on some of the higher temperature sectors to take the start of that. But there are some other technologies here today that are very excellently suited for the 1,000 degrees, for instance, steel production cases. And I think that just shows how the different technologies will complement each other in various use cases. We also think the retrofit of coal power plants and biomass plants is super attractive. We see most of the assets have 10 years lifetime left. The benefit of hydroxide salts is that they are thermally stable in principle to above 1,000 degrees. Corrosion is too high at 1,000 degrees, but at up to 600 degrees steam, it is feasible to deliver not just the temperature, but also the pressure needed to directly retrofit and fully retrofit a coal power plant and biomass plants. And in terms of Hyme's path to market, I'm going to get back to what we're doing, some of the public projects, but the dialogues are really in the industry sector, in chemistry. We expect to go through, we have 3 specific projects where we expect to go through the next gateway this year. One of the public projects that is already announced is actually in a thermal power plant. I'll get back to that. The first that we have is the Moss pilot plant. That is an industry scale pilot that was inaugurated last month. I'll show you a few pictures from that in a moment because I'm proud of that. But maybe to say a few words on the next project, it's a 20 megawatt thermal storage project that will be built inside an existing biomass plant in Bornholm, this island in the Baltic Sea, east of Denmark. It's one of the areas where these energy islands are being deployed. It is an existing island that will combine offshore power, not just from Denmark, but also Sweden and the Baltics and Germany and Poland, and that will have grid connections across. It's interesting because it allows us to build exactly inside an existing power plant, meeting all those requirements, doing the grid stabilization, but also because there are stakeholders, both German and Polish coal power plants, that are looking towards how would they actually retrofit their assets. And as mentioned already, it's attractive to look at the thermal power plant sites because they have existing grid connections and existing heat customers. So in terms of transition pace, they are very interesting. As promised, let me just show you a few pictures from the industry scale pilot we inaugurated last month. It's together with all the partners that we work with to be able to execute larger projects. We had the honor of showing around the Prime Minister end of April for that site. And I think that's not just acknowledging the interest in Hyme, but I think it shows the interest in thermal storage in general, that a head of states take the time to visit a thermal storage plant. And back to the deployment of offshore wind plants, not just in Denmark, but in Europe, there is a need for other technologies and power to actually utilize that electricity well. And the efficiency in combining or turning that into heat or combined heat and power are just very high. So it's one of the most efficient ways to decarbonize society going forward. And with that, I think it's a good place to take questions. So thank you for your time.
Perfect. So I guess we've been getting quite a few questions when it comes to molten salts in terms of what would you see as the pros and cons, and the way that your breakthrough has also helped to address some of the challenges.
Yeah, so molten salts in concentrated solar power has been deployed close to a couple of decades now. There's been some limitation on temperature and compactness and cost of those facilities. And one of the fundamental changes we are making is actually on the both energy density and also the thermal range that these hydroxide salts can deliver discharge at. It effectively reduces material consumption in the plants by 30 up to 60% and delivers a larger temperature span that we can deliver to. I think we focus at the longer discharge durations because I think that some of the other solutions present here today that would be much better at the shorter batch processes, for instance, of flexible temperatures, where we focus specifically, and that goes for all molten salts, on constant temperature and pressure delivery in steam for the longer duration discharges. Yeah, so that would be one of the things to mention.
Perfect. And you touched on it earlier, and it's been a question we've been getting quite a bit. Could you talk a bit more about the ability to simultaneously charge and discharge in terms of when you're able to go for fast charging and then discharge constantly throughout?
Yeah, it's been an active decision on our part to design the system with a two-tank system and a decoupled charge and discharge system. So charging is just done by, it's basically electric resistance heaters directly into the salt. So you get a high efficiency there, close to 100%. Those are existing. They've been adapted in the molten salt MOS project, our industry pilot, to hydroxide salts, but they existed already from the CSP sector. On the discharge side, it is a steam generator or evaporator system that is fed directly by the molten salt pump from the hot side, and that can ramp up and down very fast. So you have ramp rates that are even faster than you would have in a coal power plant on the boiler side there. What is attractive, and one of the things we are testing, is how fast we can ramp up and down the charge side, because the heat elements there, they actually act on millisecond scale, so it's more down to the thermal stability of the components and the lifetime impact that we're testing. But it's been an active decision to have these two decoupled and cater for use cases where there's a need to say fill up the entire storage system in 6 to 8 hours, capturing, in Denmark it would be wind at night and solar peaks during summer, and then discharge up to 24/7.
That makes a lot of sense. And when it came to your MOS project, first, congratulations, but two, when it came to setting it up, what kind of challenges and lessons did you learn during the process?
So I think while the global supply chains has been set for nitrate salts and solar salt, we still experienced that there was a big difference between the quality and the volume some of these suppliers had. We actually had to change members in the consortium. So that's been one barrier. We're also very happy with the consortium we have now and partners. Just announced collaboration with Alfa Laval Energy as one of the most recent announcements. And I think that just shows that it's important to ally yourself with the right partners also to get this to market at the right pace.
Interesting. And I think one final question is, do you foresee any issue with grid congestion when electrification increasingly is coming online to replace natural gas?
Yeah, I think not just molten salt, but several storage systems, they are actually a benefit to the N+1 rule you'll typically have from TSO, the transmission and distribution companies, because you can have smaller connections across countries, so smaller transmission lines, if you have local consumers as energy storage. But then again, we also want to store power when it's inexpensive at the same time that power to X will. So I think we'll need to see development plans like in Denmark, where there's an overcapacity of offshore and renewables being deployed compared to what the electricity need is, and then we'll need to show that we turn these into other sectors. And I think that is the general story today, that these are technologies presented today that are excellent at exactly that.
Perfect. No, I think that's been great. Thank you very much.
Excellent ask. Thank you very much.